probability lecture 6 আমরা আগে স্যাম্পল স্পেস তারপরে এরকম প্রবাবিলিটি কাকে বলে ডিফারেন্ট অ্যাক্সিওমস প্রপার্টিজ রেজাল্টস দেখেছিলাম তারপর সেখান থেকে আমরা র্যান্ডম ভেরিয়েবল কন্ডিশনাল প্রবাবিলিটি ইন্ডিপেন্ডেন্সি and then last ক্লাসে আমরা র্যান্ডম ভেরিয়েবল দেখেছিলাম সো আজকে হচ্ছে today class is on the distribution also we done distributions today class on the different properties of distributions and different distributions so some distribution this is called theoretical distribution theoretical distributions and there are different expectations and variance etc so just brief recapitulation what is theoretical distribution is actually what is distribution we know this is a function from real number to real number such that f of minus infinity is 0 that is limit is just that is limit extends to minus infinity fx is 0 then f of this f is actually not from 0 it is from 0 to 1 close interval so fx is lies between say 0 to 1 and this is 1 which is that is limit extends to infinity is 1 fx is 1 and f is increasing function and the most important part is the limit extends to or y tends to x plus is right hand limit which is sorry it is fy is fx so it's called right continuous now if this is a continuous if f is a continuous distribution this is true for continuous and discrete both but if it is a continuous distribution then limit y tends to x minus fy is also fx so it is actually continuous so it is continuous so that is why it's called continuous but if it is discrete then it is may not be left continuous some point is continuous some point is discontinuous it's right limit exists but left limit does not exist why this is so we just take a very simple quick example so this is a very easy example say we have a random variable which takes only two values say it's also called spec the what value of value x takes is called spectrum it's full form is spectrum say 0 and 1 only two just head and tail say so head is 1 and tail is 0 so spec of x is 0 1 and this is the probability of x equal to 0 say 0.4 and probability of x equal to 1 is say 0.6 now what is the distribution function and what is the definition of this fx is probability of x less than or equal to x now what is the probability of say x less than or equal to say minus 1 what is this so it is 0 just 0 and 1 so it is 0 so f of minus 1 is 0 similarly f of minus 2 is 0 f of minus 7 is 0 what about f of say f of minus 1 is 0 f of say minus 0.00000001 again it is probability of x less than minus 0.00001, which is again 0. Because it's just less than 0, so it is 0. That means what happened? What is the function? What is the graph of the function? The graph of the function is like that. So it is here, it is just 0. Every for negative value, for each negative value it is 0. And this is just open. What about f0? f0 is probability of x less than or equal to 0, which is just probability of x equal to 0. Only one value. It is 0.4. What is point f of say 0, 5, 9, 6, something like that? Again, it is 0.4. What is f of 0.99999 say? Again 0.4. 0.999 also 0.4. 0.99999 is also 9.4. But what is f of 1? It is the probability of x less than or equal to 1, which is for x and 0 both is take. So it is 1. That means, so it is from here, so at 0 it is 0.4, up to before just 1 is open interval 1, it is just 1, it is 0.4, and at 1 it is just 1. Now f of 2 is 1, f of 3 is 1, f of 100 is 1, f of 1 core is 1. So this is the graph of the distribution function. So it is left discontinuous at 2 points, 0 and 1. Otherwise everywhere it is continuous. Everywhere it is continuous except 2 points. 2 points is 0 and 1. At 0 it is, and at 1 it is left discontinuous, right continuous. So it is, that should be always right continuous. So for this case, but if it is a continuous random variable like normal or Mosso, then it will be everywhere it is continuous. So sometimes discrete and continuous random variable is distinguished like that. That if the distribution function is continuous, then this is a continuous random variable. And if the distribution function is not continuous, somewhere it is at finite limit point or countable limit point, it is discontinuous, means it is left discontinuous, then it is discrete random variable. So this the last one, that random variable takes only two values, 0 and 1. Say probability of 0 is a q, and probability of x equal to, say it is 1 is p plus q is 1, and p and q both positive. Then this random variable has a name. It's called Bernoulli random variable. Sometimes, right, follows. This is this symbol for follows. This tilde. This symbol name is tilde, but we say it is follows. This is a tilde. This symbol is called tilde. The name of the symbol is tilde, but we say the x follows Bernoulli p. If you say x follows Bernoulli p, that means x takes only two values, 0 and 1, and for x equal to 1 it is just p. So they are simplest random variable. Simplest. How this Bernoulli random variable derive or occur in real life? It is just called success and failure experiment. There's only two outcomes. Say we toss a coin, and it is either head or tail. Toss a coin is either head or tail. The sample is either head or tail. So if it's head, then the random variable is like that. Its head is 1, and then tail it is 0. And maybe it is half, or maybe 0.4 or 0.6 probability or whatever. We can define random variable like that. Say if it is h, we say it is 7. Say x of h is 7 and x of t is say -3. Then also it is a success failure experiment. But this random variable we will not say this is a Bernoulli. It is just a, it's like a same like a Bernoulli. But the value is not 0, 1. It's just -7 or 6. So it is better to take 0 and 1. Why? If I say it's a head is 7 and tail is -8, or if head is say 2.39 and x of tail is say minus e to the power e squared, it's very complicated. Why should we do this? We want to we introduce random variable to life makes simple. So that's why it takes 0 and 1. So 0 means it is 0 head, and 1 means just 1 head. So it's easy to interpret. That's why we take this random variable, and this is called Bernoulli. Bernoulli is the famous name of a famous mathematician, John Bernoulli. So it's a Bernoulli distribution. Now toss a coin on this. So there are several other also say we shoot a ball to a goal, and it may be goal or maybe either goal or not. Again, it's a success failure. So probability of goal is say 0.2 and say probability of not goal is say 0.8. Similarly, if you shoot by a gun, it may be it hit the target say probability 0.2 or it's not hit the target say 0.8. So same experiment, not sorry, it's not the same experiment, but the ultimate idea is same. It's just success and failure. So in this all this experiment, there are several experiments maybe shot by a gun or maybe shoot a ball or head tail or any other success. It's just there is a question say true false, and a students randomly tick this. You don't know what is the answer of true or false. It's randomly tick true and false. So it may be true, it may be false. It is a 50-50 chance. It's again the Bernoulli with probability halves, p equal to half. So there are several experiments, but ultimately this is the modeled by this Bernoulli distribution. So there's no need of discuss or no need of study all this experiment. We just study a single experiment like head tail, and every other that shoot by a gun or shoot by a ball or is a true false problem. Actually, the same thing. It's just the interpretation is different. It is head tail. Here is hit the target or not hit the target, like that. Is a true false, is correct answer, false wrong answer. Just the interpretation is different. Otherwise, everything is exactly the same. So this is called Bernoulli random variable, and this random variable has something we have to find. One is called expectation. This is called expectation of a random variable. What is this? So by definition, expectation of x is just sum over all x. I am not writing it may be finite or infinite. That's why I not write say x equal to 1 to n or maybe x equal to 0 to infinity maybe. So I just write x. So that x into probability of x equal to x. This is the by definition is expectation. So what is the expectation for Bernoulli? So if it is a Bernoulli, P, then this expectation is just x is 0 into the probability of x equal to 0 and 1 into the probability of x equal to 1. So that means it's just probability of x equal to 1. So it is just P. Just P. Where is it? It is just P. Expectation is P. Expectation something like average. So if say P is say 0.3 is the probability of success is 0.3, then on an average there are 0.3 head. This is nothing actually, no meaning of that. So what is this meaning? If you have 100 many toss, 100 many Bernoulli turns is also called Bernoulli turns. The experiment is called Bernoulli turns. Say 0.3, then it's 100 many toss, then it is 30 head approximately. I mean 28, it may be 32, but on an average is 30. So 0.3 into 100. So this is the basic idea of expectation. Now, what is again? There is one more thing. It's called variance. What is the definition of variance? There are three equivalent formula for variance. The definition is just this: x minus expectation of x, that square, into probability of x equal to x. Sum over all x. This is the one formula. Another equivalent formula is this. It's better than the previous thing. X square into probability of x equal to x minus expectation of x and then whole square. And the other one is also important. Is x into x minus 1 into probability of x equal to x minus expectation of x into expectation of x minus 1. So these are the three equivalent. Same thing. You can easily prove that. You can easily prove one from the other. So for Bernoulli, so for if x is Bernoulli, sorry, it is x follows Bernoulli P, then what is the variance? Variance is, it is just say sum over x square, so it is x square into probability of x equal to x minus expectation of x square is just p, so p square, so it's x square, so if it's x equal to 0, so 0 square 0, 1 square just 1 into probability of 1 is just p minus p square, it is p minus p square, which is p into q. So this is the variance of this Bernoulli random variable. Next is just slightly non-trivial example. It's called Bernoulli binomial random variables. It's called binomial n comma p. How it is kept? This came from a toss n many times. So the Bernoulli toss is n many times, and we want to find the number of success. How many success are there? How many head are there? If head is a success, so how many shot hit the target? And again, this then the spec of x, the value may be 0 or 1, maybe 2. By the way, this n is a natural number, and this p is lies between 0 and 1. It's a probability of success. It's maximum n and the minimum is 0. Now, what is the probability of x equal to say r or x equal to x? It's just ncx p to the power x and 1 minus p to the power. By the way, this is we have to modify, slightly modify unit. For Bernoulli, for binomial we should say one more thing. We should say probability of x equal to x is 0 if x not belongs to this 0 and 1. Other than 0 and 1, say x equal to probability of x equal to 2, this is 0. Probability of x equal to 5, this is 0. And what will be the distribution function then? Up to 0 it is 0. From 0 to 1 it is half. And again from 1 to right side is 1. So these are distribution functions, the opposite distribution function. So it is just half, and this is just 1. Along this we put x, and along this we put capital X. So we should say this is n minus x, just n minus x. Now x is belongs to the set 0, 1, 2 up to n. Now if x does not belong to this set, is other than this 1 up to n, so does not belong to the spec, then that must be 0. Obviously, it's not only for this binomial, it's for everything. This for every discrete random variable, if the x is not in the spectrum, then we say then obviously the probability is 0. So why this is so? This is clear because if I have n many toss, and if there are x success, that means say in say 10 toss there are 3 success, that means 3 heads, and rest n minus x are tail. So there are x many heads and n minus x many tails. Other failure. So what is this probability? So if I say x many heads, head, then tail, what is the probability? This probability is nothing but p into they are independent. I must say this: the tosses are independent. So with the same coin, independently, repeatedly and independently. So it is p, and then q is just 1 minus p. So it is just p to the power x, 1 minus p to the power n minus x. Now this is not only this is not the only choice. You have several choice. Something like say head, then tail, head, something like that. Tail, head, tail. So then also it is probability is same. Now how many arrangement are there? So there are x heads and n minus x tail. So how many we can arrange this x head and n minus x tail? This is the ncx. So there are n objects. Among n objects there are x heads. So we have to rearrange this x head in n positions. So it is ncx. So ncx many outcome are there, and every outcome has a probability p to the power x into 1 minus p to the power n minus x, and this must be add because they are mutually exclusive. So we just add it. Obviously it is mutually exclusive because these two cannot hold at a time. So head head tail and head tail head cannot be hold at a time. It is just a mutually exclusive. So you just add this all this probability. The same probability ncx many times, so it is ncx into p to the power x into 1 minus p whole to the power n minus x. So this is the probability. So what will be the expectation? So now this is tricky. You have to find expectation from 0 to n. You have to add 0 to n. So x into probability of x equal to x. So it is just ncx p to the power x 1 minus p to the power n minus x. So it is slightly tricky. Now for x equal to 0, we just omit this thing. So we can just say x equal to 1 to n because x equal to 0 is 0. X, and what is ncx? Ncx just n factorial by n minus x factorial into x factorial p to the power x 1 minus p to the power n minus x. Now we just cancel this x, and so x equal to 1 to n, we get n factorial by n minus x factorial and then x minus 1 factorial. Now we take just n into p common. This is slightly tricky. This line is a key line. This is a most important tricky line. So you just take np common. If you take np common, it is n minus 1 factorial. You take n common from the n factorial is n minus 1 factorial. And this is p to the power x minus 1 and 1 minus p to the power n minus x. So what is this? You just think a little bit and you can easily see that it is actually p minus q whole to the power x minus n minus 1. Why? Why this so? So this is, you can just using binomial theorem. So again, the sum of the all probability must be 0. Sum of the probability must be 1, and that is coming from binomial. So if you add all these probabilities of x equal to x from x equal to 0 to n, which is just ncx p to the power x 1 minus p to the power n minus x, which is q. So it is the q equal to 1 minus p. So p minus p plus q is 1. So it is just q. So it is just p plus q whole to the power n. We know this. This is called binomial theorem, and that's why this random variable is called binomial random variable. Now, why this is p plus q whole to the n minus 1? You can easily see this. So p plus q whole to the power n minus 1 is, what is this? It is just n minus 1 c0 p to the power n minus 1 and or p to the power say 0. Say first term is 0, so p to the power 0 q to the power n minus 1. Then the next term is n minus 1 c1 p to the power 1 q to the power n minus 2, and da 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 da. The last term is n minus 1 cn minus 1 p to the power n minus 1 q to the power 0. Now this is exactly the same. Why? Exactly the same. Just put x equal to 1. If you put x equal to 1, you will get this term. Check. It is nc n minus 1 factorial by n minus 1 factorial into 0 factorial p to the power n minus 1 q to the power p to the power 0 q to the power n minus 1. Exactly the same term. If you put x equal to 2 here, you will exactly get this term. X equal to n minus 1 factorial by n minus 2 factorial into 1 factorial, which is exactly n minus 1 c1, and p to the power 1 and q to the power n minus 2. And dot 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 dot, you put just x term. So exactly the different form. This is actually the equal to 0 to n minus 1 n minus 1 factorial minus x factorial and then x factorial and p to the power x and q to the power n minus 1 minus x. Exactly this two are same. You just put x equal to 1 in the upper one and just put x equal to 0. Same expression. You put x equal to 1 in the lower, x equal to 2 in the upper, you get the same. You put n minus 1 in the last one and n in the upper one, you'll get the same thing. Exactly the same. Put x minus 1 equal to y something, it will be the same thing. So that's how it is, and so it is, we get NP. So what is the expectation of this random variable? If x follows binomial n comma p, that is just n into p. And this is slightly obvious because say if probability is say uh, success probability, and say it was 100 times. So if it was 100 times, if probability is say 0.7, then on value of this success is 70, and that's why the expectation n into p is a success on an average success. So that's why is the name is called expectation. On an average, what we expect. So what is the variance? Variance will be, now you have to find variance. Now variance, we need that formula, x equal to 0 to n. We need the last one is the important here, minus np whole square. Oh sorry, not np whole square, np into np minus 1. Now if you can put from 2 to n, so because if x equal to, it will give 0, and again it is n factorial by n minus x factorial and x factorial minus some np into np minus 1. It's just same trick. Minus x factorial and then x minus 2 factorial, and then it is n square p square plus np. Next, rest are the same trick. You just take n into n minus 1 p square common. Oh, sorry. There must be p to the power n minus x. P to the power x, q to the power n minus x. So you take p square common, then x equal to n minus 2 factorial into n divided by n minus n factorial x minus 2 factorial, and then p to the power x minus 2 and q to the power n minus x. The rest are n minus n square plus n square p square plus n. And you can easily see that by the same trick, this is nothing but p plus q whole to the power n minus 2. Same thing. It's coming from 2 to n. And if you just replace by y, x minus 2 is just y, then it is y equal to 0 to n minus 2. Same thing, same term. Once we put y equal to 0, you'll get x equal to 2, y equal to 0, the same term. Now p plus q is 1, so we get square p square minus np square minus n square p square plus np. So it is just np minus np square, so it is np common, so it is 1 minus p, so it is p npq. So the variance is just npq. And the binomial random variable as by variance npq, and this Bernoulli is nothing but binomial 1, just n equal to 1. You put n equal to 1, you get binomial random Bernoulli random variable. So Bernoulli is a special case of binomial random variable. So this is a very important distribution. There is other distribution. One is called discrete uniform. It's also called uniform or discrete uniform. It's just x, the spec of x is then it's just very simple, say 1 up to n. It's just from 1 to up to n, maybe 0 to n, and all the probability are equal. So that's why it's uniform. So all this probability is 1 by n. Again, this is for x belongs to that set, that spec. And if the x does not belongs to the set, then it is 0. Then it is just 0. So it is called uniform, and you can easily find what is the expectation of this random variable. It is the sum over x into probability of x equal to x, which is nothing but from just 1 to n. You can take 0 to n, If you take 0 to n, then it is 1 by n plus 1 each probability. Then it is just x equal to 1 to n, x by n. And we know the sum of this 1 up to n is x is just n into n plus 1 by 2. And so it is just n plus 1 by 2. You can similarly calculate the variance, and variance is just put x square 1 by n, x equal to 1 to n minus n plus 1 by 2 whole square, the expectation. So variance is the other formula, x square probability of x equal to x minus expectation of x whole square. And you know, just take 1 by n common, as summation of x square is just n into n plus 1 into 2n plus 1 by 6. And these formulas are in class 11, you know. And this is just n plus 1 into n plus 2n plus 1 by 6 minus n plus 1 whole square by 4. Ultimately, what we get? Ultimately, if we take n plus 1 by 12 common, then we'll get 4n plus 2 minus 3 into n plus 1, which is just n in n minus 1. So it is n square minus 1 by 12. So this is the variance. This is a theoretical distribution, and there are several distributions you can just write as your choice. You can say x equal to 1 is say 0.3, x equal to 9 is say 0.1, x equal to 13 is say 0.1, x equal to minus 5 is say 0.2. You can, it is your choice. You can write anything. But two things you have to remember, that the sum of the total probability must be 1, that add up to 1, and this all must be positive. It can't be negative. So these are very important. Some finite distribution. There are other distribution. One is called hypergeometric distribution. This is very important to calculate something, a ratio in somewhere. So what is the ratio of smokers, to find what the ratio of smokers, or what is the ratio of some object among some objects. So what is the ratio of a blue ball among the whole? There are say two type of balls, a blue and black. You don't know how many blue are there. So this distribution is very important to find what is the ratio of blue. What is the percentage of something? So what is the percent of say COVID positive among the all thing, like that. So this thing to find some percentage, some ratio. How many are illiterate, something like that. How many are interested of this thing. So this hypergeometry is a very important part. These are the most important finite distribution, and there are several infinite distributions. One infinite distribution is called Poisson distribution. So the distributions are say hypergeometric, and the infinite is a Poisson distribution, Poisson, and these are these are important. So you just the one finite is hyper. There's other negative binomial and others. So hypergeometric and Poisson are very important. These are discrete. And next, there are continuous distribution. Is continuous uniform. It's called rectangular distribution. Then there's the most important distribution we know. It's called normal distribution. And there are other distributions like chi-square and this beta, gamma, f. There are several distributions, but these are important: hypergeometric, Poisson, binomial, uniform, rectangular, and normal. And we have to find these distributions, expectation, variance. There are other thing also is you can find like mode, like quartile, median. Finding mode of the binomial distribution, you know, this is in your class 11. Actually, finding mode of mode means the maximum value, maximum probability. The finding the mode of this binomial distribution, nothing but the finding the maximum value of in the binomial expression p plus q whole to the power n. So p plus q whole to the power n, what is the maximum value? You know, what is the maximum value in x plus y whole to the power n? That we find in the class 11 book. We have this. So I just write what are these distributions, what are the probability, In next class, we'll elaborately discuss on that. So also hypergeometry is something like that. Say in a pond, there are some fish. Say there are n many fishes, or there are n many balls. You can like fish or ball, or maybe particles, anything, or maybe parts populations. And among them, you just take n of them out, small n. Obviously, n is less than n, and you just mark this fish and you just put again in the pond. That means there are now two types. It's a marked type. Marked type is n, and unmarked type is n minus n. So that may be maybe some ball, black ball and blue ball, white ball. That may be some positive, negative persons. Something positive, something, or maybe some are interested, non-interested, smokers, non-smoker, anything we can. Now next you take just say m many balls. Now in m many balls, what is the probability that r x many balls are marked? Now we know this. There are total n capital many balls. So taking m many balls, you can choose m c m many balls. You know that this is denominator. And what is the probability that the marked ball are among m? Marked ball are x and unmarked is m minus x. So marked ball is coming from n. So it is ncx. And unmarked is coming from n minus n. So n minus n c m minus x. This notation is for C, N, C, X. You know, this notation is for combination. Now, this is the probability of x equal to x. So, x equal to number of marked fish or number of something, say number of smoker, like that. So, there are two type of things. Now, there is a condition because you should have some condition. Something that first condition is m must be less than equal to m, and one is x must be less than or equal to n. And greater than equal to 0, all are integer. And other condition is m minus x must be greater than equal to 0 and less than equal to n minus n. So what is the condition on x then? So condition on x then actually x is less than equal to m from there. So x is not only less than equal to, it is less than equal to m also. And from here we get x is greater than equal to, condition is m plus n minus n. So that means your x is lies between the maximum value is minimum of these two, minimum of n or m, and it must be greater than equal to maximum of 0 and this m plus n minus. So if m plus n minus n is say positive, say 3, we can't take x equal to 0, 1 or 2. It must be from starting from 3. So this is the range, and if this is so and if this is not in the range, then probability is 0. So this is called hypergeometric distribution. And finding mean, expectation and variance is slightly complicated here. So not going in there. And the last one is a Poisson distribution. This is the final distribution. Next class I will talk on the continuous distribution, or maybe I'll stop my class in the next class, maybe one or two class, one class for that that all this your doubt. Now probability of this Poisson distribution is because x follows Poisson like p called lambda. This is infinite distribution. The fast infinite thing. Spectrum of this is 0, 1, 2, dot, 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 any non-negative integers. Now, what is the probability of this? Probability of x equal to x is, how can we remember that? There is one idea to remember that. If you forget how to write this, so idea is this. So what is e to the power lambda? What is the e to the power lambda? Even though the Taylor series expansion of the e to the power lambda is 1 plus lambda square by the way, this lambda must be, this is a probability, so it is 0 to 1, between 0 and so this is lambda cube by factorial 3. We know this. Now the idea is this. So if you have a 1 here, so you have to multiply e to the minus lambda with this. So lambda into the minus lambda square to the lambda square minus lambda. So this is the basic idea to remember how to write this probability. And this is nothing but e to the power minus lambda, lambda to the power x, x factorial, 0, 1. So this is the polity. So x equal to 0 is the first one, x equal to 2, 1 is the second one, x equal to 3, this, x equal to 2, this one, third one, x equal to 3, this one. It's just the term in this e to the power lambda expression and multiplied e to the minus lambda. So it is just that term, x equal to x equal to 5 or 6. And obviously this sum is 1. So if you forget, you just write, you can easily write this probability using the e to the power lambda series. And what is this expectation of this? Expectation, to find the expectation is rather easy, easier than binomial thing. Once it's rather easy because there are only one parameter, lambda, because in binomial there are two parameters, n and p. So it is very easy. Somewhat x equal to 0 to infinity, x to the power x into probability. What is the probability? To the power minus lambda, lambda to the power x by factorial x. And again, you can just start from 1, because if x equal to 0, then it is just 0. And you can just take lambda to the power x, e to the power lambda minus lambda common, and this from x equal to 1 to infinity, it is lambda to the power x by x minus 1 factorial. So again, you just take lambda common, the same trick, and it is just again e to the power lambda series. Same thing. If you put x equal to 1, you will get just 1. If you put x equal to 2, you get lambda. If you put x equal to 3, you will get lambda square by 2 factorial. So it is just e to the power lambda. Same idea in binomials. So it's just lambda. So expectation is just lambda. And what is the variance? Again, is the last one. So it is just sum over for the last formula. We use the last formula, sum over x equal to 0 to infinity, x into x minus 1 into the probability. Probability is this, minus expectation of x into expectation of x minus 1. Now this is x equal to 0. You can start with 2. So you can start with 2 and take e to the minus lambda common. Lambda minus 1. We are almost in the last step. It is just x to the lambda to the power x by x minus 2 factorial, and you start from 2 to lambda minus lambda square plus lambda, and again you just take lambda square common now to get the series e to the power x series. So it is 2 to lambda infinity, lambda to the power x minus 2 by x minus 2. Again, this is e to the power lambda, nothing but this series e to the power lambda. This is just e to the power lambda. Again, same thing. If we put x equal to 2, it is just 1. X equal to 3, it is just x. It is a lambda. If x equal to 4, is lambda square by factorial 2. So it is just e to the power lambda into e to the power minus lambda. So lambda square is just 1. So it is lambda square minus lambda square plus lambda. It is just again lambda. So variance and expectation is same for the Poisson distribution. The important observation: the variance and expectation are same for the Poisson distribution, and for binomial, the variance is less because npq is less than np, because q is less than 1, strictly less than 1. So, and for hypergeometric, the variance will be the greater. If you just calculate, it is just homework. You just calculate the hypergeometric distribution and expectation variance. You will find the variance is more than the expectation for hypergeometry. So that's all for this class.